Hello. In this presentation we will explore the subject of soil testing and how this practice relates to the cultivation of vegetables on the commercial scale. This presentation was made by Shelby Henning and Jeff Kindhart and is narrated by Mike Kruger, who is the foreman at the St. Charles Horticulture Research Center. One question that is often asked is whether a soil test is necessary to grow crops successfully. While the fact remains that many people with home gardens successfully grow produce without ever taking a soil test, the simple answer to this question is yes. Testing is a necessary tool for optimal yields. Another question frequently asked is what sort of soil test should be done. The testing in question should not be done with an inexpensive garden or hardware store testing kit. While inexpensive, these tests tend to be awkward to use and give either incorrect or no results. The soil test should be done by an accredited laboratory that is specialized in soil testing. For Illinois growers, an easy way to find a lab that performs quality soil testing is to consult the Illinois Soil Testing Association website. Not only will this provide you with a testing laboratory, but oftentimes the lab in question will guide you as to what steps should be taken to ensure a representative soil sample. A further point to consider is that not all labs offer the same tests, but if the lab is accredited, it will have a qualified standard set by the Illinois Testing Association, which assures a high level of testing accuracy. Most labs will offer a standard soil test that consists of a soil pH, phosphorus, and potassium. Frequently included in a standard test is the lime index, buffer pH, used to make the lime recommendations, calcium, magnesium, which are important secondary nutrients, and the cation exchange capacity, which measures the soil's ability to hold positively charged nutrients. Also, not all labs will cater to the home or small grower. Additionally, many labs offer specialized analysis not included in a standard soil test, as well as provide recommendations regarding your test values. Additionally, not all tests are 100% accurate. Many test values can change even on or within a replication of the same soil sample. While not all the tests are 100% accurate, most test results have been correlated over many years of repeated trials to make them useful tools for fertility management. There are several ways a soil sample can be obtained from the field. Most samples are taken from a depth where the crop is expected to form a majority of its roots. Many labs will specify how deep a profile should be sampled. Common tools to obtain a soil sample are the soil probe, auger, or a simple shovel or spade. When taking soil samples, enough samples should be taken to yield a representative sample of the area to be farmed. Areas on the farm that are different, meaning high or low areas, areas prone to flooding, or where you see different crop response, should be sampled by themselves and a separate test should be done for them. One resource that is helpful is the USDA collection of online soil surveys. These are available for each state and each county in that state. You should be able to find your farm on the survey and obtain useful information from it regarding particular differences for your land. Another valuable aspect is if you are looking to purchase land, you can look up the land or farm on the soil survey and determine if it is suitable for agronomic pursuit prior to purchasing it. Of course, cost can become an issue as samples increase, and this sampling recommendation is a guideline rather than a rule. The law of diminishing returns also applies to soil sampling. One of the most important portions of the soil test results is your soil pH value. Soil pH controls nutrient availability of the soil solution. Thus, soil pH is the foundation of fertility for crops. If your pH is not balanced for crop production, no amount of fertilizer will remedy potential yield losses. There are several ways to measure pH. The low-tech methods of reactive dyes and pH indicator paper tend to be not as accurate and as a properly calibrated pH meter. The downside of a digital pH meter is they can be quite expensive. The pH scale is bounded by the values of 0 and 14. A value of 7 is considered to be neutral. A value below 7 is acidic and referred to as low or acid. A value above 7 is considered to be high or basic. In general, a pH value of 6.0 to 6.8 is ideal for most vegetable crops. The native pH of Midwest soils varies from quite acidic, a pH of 5 or lower, to quite alkaline, which is a pH of 7.5 or higher. There are some exceptions, for example acid-loving crops such as blueberries and cranberries. If your soil pH falls outside of the range of acceptability, it should be adjusted. If your pH is too high, meaning basic, it will have to be acidified. There are many ways to acidify soils, but the most common is the use of elemental sulfur. Elemental sulfur is acted on by soil microorganisms to generate oxidized sulfur and acidity, which in turn lowers the pH. The amount to add is predicated by your starting pH and your soil type. The practice of acidifying soils for vegetable culture in Illinois is somewhat rare, as many farming practices tend to reduce soil pH. There are some caveats with soil acidification. While iron and aluminum sulfate can also be used as acidification agents, granular sulfur is the cheapest and most readily available soil acidifying agent. Since sulfur for this purpose is granular, it takes time to carry out the acidification process. You should never apply more than 2 pounds of sulfur per 100 square feet per application. Application should be spaced out in at least 3-month intervals. Don't apply sulfur to crops growing in the field. You'll have to retest your pH frequently to assess the rate of your pH changes in the field. If your pH is too low, which is a fairly common occurrence for farming operations, it should be adjusted accordingly. Limestone, which is either calcium or magnesium carbonate, is generally used for raising the soil pH. Again, your initial pH and your soil type will predicate how much lime will be used to make the necessary adjustment. Not all lime is created equal. Finer particle sizes result in quicker action. Large lime granules take a very long time to break down and affect soil pH. Adjusting soil pH may sound complicated, but most reputable labs will generate an analytical report regarding your soil test and recommend how much lime or sulfur to add to modify your soil pH to optimum. Phosphorus is considered to be one of the major elements needed by plants for optimal physiological functioning. The amount of phosphorus supplied by soil varies throughout the state. There are several ways soil phosphorus can be tested. The optimal soil phosphorus test for most, if not all, of Illinois is the Bray-Kurtz P1 extraction method. Phosphorus fertilization guidelines are based on the soil test values, the type of crop being grown, and the estimates of phosphorus crop removal. The Midwest Growers Guide recommends a supplemental phosphorus fertilization if the Bray P1 test is less than 40 parts per million. If your soil test is higher than 80 parts per million, no phosphorus fertilization is needed or recommended. In general, applying phosphorus fertilizer at 90 to 100 pounds per acre will increase the Bray P1 test level by about 10 pounds per acre. Further recommendations are available from the University of Kentucky Extension publication ID-36, the Vegetable Production Guide for Commercial Growers. These recommendations differ depending on the target crop. In this example, rates are given for the cultivation of tomatoes. Again, these are guidelines and not rules. One element you do not want to apply in excess is phosphorus. Over-fertilization with phosphorus can cause an out-of-balance situation where the crops do not grow normally. Phosphorus can also pollute the groundwater and cause algae blooms. Since phosphorus is relatively immobile in the soil once it is applied, care should be taken not to over-fertilize to cause an out-of-balance situation because it can be very hard to correct. Potassium is another nutrient needed in large amounts by plants to function correctly. As with phosphorus, the amount of potassium supplied from the subsoil differs due to geographical region. In general, the upper two-thirds of Illinois is considered high in potassium, whereas the remainder of the state is considered low. Again, testing is via the use of an extractant, which is then analyzed by various methodologies to yield a test value. As with phosphorus, potassium fertilization guidelines are based on the test value, soil characteristics, and crop being grown, along with the estimates of crop removal. The Midwest Growers Guide recommends that potassium fertilization occurs when test values are less than 85 for soils with low cation exchange capacity and 115 for soils with medium cation exchange capacity. When test values are greater than 135 for soils with low CEC and 165 for soils with medium CEC, indicates that extra potassium fertilization is unnecessary. Additionally, the maximum potassium recommendation, regardless of test value, is the application should not exceed 300 pounds of potassium oxide per acre per year. Again, the University of Kentucky gives potassium fertilizations guidelines for individual crops. Nitrogen is the nutrient needed in the greatest quantities by plants for optimal growth. Unfortunately, a standard test is not currently available to predict how much nitrogen a vegetable crop will require. There are several ways to determine how much nitrogen you need to apply. One valuable tool is to conduct an on-farm trial to optimize your crop's nitrogen requirement. Nitrogen fertilization is mainly going to be based on your soil type. For a sandy soil with low CEC, heavy fertilization is going to make a greater difference than on a soil that has high organic matter. While there is no perfect test for nitrogen yet, there have been many attempts. The soil nitrate to nitrogen ratio values prior to pre-plant or side dressing have been used for crop nitrogen recommendations. More recently, the Illinois Soil Nitrogen Test, or ISNT, have been developed as a means to determine if a site requires nitrogen input to increase yield. This test requires much more research before it can be used effectively to estimate crop nitrogen needs for vegetable cultivation. Additionally, soil incubations followed by inorganic nitrogen analysis have been used experimentally to estimate crop nitrogen needs, but are not frequently employed by growers to a great extent. Nitrogen fertilization guidelines are going to depend on what crop you are growing, along with the population of crops being grown in a certain area. One point to remember is that specialty crops such as vegetables have different requirements for growth and development than field crops. Any nutrient that is not present in sufficient amounts will reduce crop yield. Therefore, looking at Justice von Liebig's law of the minimum, which states, plant growth is controlled not by the total amount of resources available, but by the scarcest resource. This basically says you can have all the nutrients there for plant growth, but whatever is in the scarcest amount is going to actually dictate how much that plant actually grows. Other differences regarding specialty crops versus traditional field crops are due to fertilizer options, timing, and application methodology. Specialty crops are generally high value, such that fertilizer input costs is not normally a significant cost of producing a crop. Again, more is not necessarily better. Other differences regarding specialty crops versus the list of recommendations seems endless when determining ways to adjust fertility needs in the field. One of the cheapest and most important ways to determine if you've got it right is to scout your crop, meaning not from the window of your truck, but to physically get out and inspect it in the field. Some growers rely on fertility programs developed by a number of differing sources. Some are sound, some are not. Two approaches that can yield quick information about how the plant is performing in the field are tissue analysis and petiole sap testing. Tissue analysis is complex and generally reserved for situations where the cause of the plant decline cannot be readily explained by soil testing or visual inspection. A quick way to determine how well a crop is performing is to conduct a petiole sap test. Petiole sap testing is a simple process that provides rapid test results for nitrate-nitrogen ratios and potassium concentrations in plant tissue. Sap testing is particularly useful in making adjustments in nitrogen and potassium fertilization to plants fertilized through fertigation. An important point to consider is that sap testing is a management tool and is no way should be used to replace standard soil testing. The procedures for sap testing are relatively straightforward. Petioles should be from recently matured leaves that appear to be in good condition. Collect approximately 25 petioles per sample. A sample can be obtained from several different plants of the same variety so as not to adversely affect single plants by removing most of their foliage. Petioles can be stored for a short time, but should be analyzed as soon as possible after picking. Extraneous leaves should be removed as well. Prior to sap analysis, make sure that you understand how to use your meters. If petioles have been stored at cool temperatures, let them warm up to room temperature. Cut the petioles into small pieces that will fit into a handheld plant sap or garlic press. Analyze the sap with appropriate meter and compare the values to a previous test value. Adjust fertilizer inputs accordingly. Guidelines have been established for adequate concentrations of nitrate-nitrogen ratios and potassium in many plants. Consulting these guidelines can help you in your fertility management decision making. Fertigation is the application of fertilizers or other water-soluble products through an irrigation system. The practice is similar to chemigation, but chemigation differs from fertigation in the fact that it refers to the application of pesticides through irrigation systems. Fertigation is a convenient way to deliver fertilizer to plants throughout the growing season. It also allows flexibility in what and how much of a product you apply to your crop. There are important points to consider prior to installing a fertigation system. The most important is the use of a backflow prevention device so that chemicals do not contaminate the water source used for the fertigation system. The EPA and many state and local regulations require backflow systems. This is especially important if you are using a municipal water source for your operation. If you are not certain whether you require backflow prevention, consult your appropriate state or local agency. You should check or have a backflow prevention system checked yearly to ensure it is working correctly. A backflow might also be required by your state or local agency to be installed by a licensed professional. Some recommendations are based on the total nitrogen required by a crop. 1/3 to 1/2 of the nitrogen required for the season is applied as pre-plant fertilizer. The rest of the nitrogen is applied in even doses on a weekly schedule. The amount of nitrogen required will depend on the crop being grown as well as the plant population. This example is again from the University of Kentucky regarding nitrogen fertigation of staked tomatoes. Remember that sap testing is a valuable tool that can assist you in precision fertilization of your crop, and that these feeding schedules are recommendations and not immutable. Common fertilizers used for fertigation are those that contain nitrogen, calcium, potassium, phosphorus. Is not commonly used as it can precipitate and clog emitters. Be careful when mixing different fertilizer materials because some are incompatible and will cause clogs as well. In conclusion, I highly recommend on-farm tests of fertility. Explore which rates work for your desired crop on a small scale. Remember that your extension agents are quite knowledgeable about commercial vegetable culture and can assist you if you run into trouble. Get to know who they are in your county and get to know them. Remember that retesting your soil every few years is essential in conducting a quality operation.